Welcome to question 6. Okay, so question 6 is our Doppler effect question, and the Doppler effect question is usually very simple, usually up to about 15 marks. Not a very difficult question, not very many different ways they can ask it. So my recommendation to everyone is to really practice this question continuously until you can answer almost any type of Doppler effect question, because it really isn't that difficult and there's not a lot of ways in which they can ask it. So this one, Karabo is on a roller coaster screaming at the top of her lungs at 700 hertz while traveling towards you at 35 meters per second. Describe what is meant by the Doppler effect. And next is calculate the frequency of the sound that you will observe coming from Karabo's screaming. And finally, explain how Doppler effect is used in astronomy to suggest that the universe is expanding. Okay, first, describe what is meant by the Doppler effect. What is the Doppler effect? Well, it is the apparent change in frequency, in observed frequency. In other words, the frequency doesn't change, it is observed to change. Frequency means the number of waves that pass at a certain point. Now that frequency stays constant, but when an object is moving, observing that frequency increases or decreases depending on the relative motion of the objects. So describe what is meant by the Doppler effect. It is the apparent change in the observed frequency. Very important, there is observed frequency. That is, or in the frequency observed by due to the relative motion of the emitter or the listener. So yeah, hopefully that makes sense. Next question, calculate the frequency of the sound that you will observe coming from Karabo's screaming. You may assume that the velocity of sound is 343 meters per second. Okay, so when it comes to the Doppler effect calculation, it is very straightforward. And I only use one formula. I use the formula that the frequency observed is equal to, so if I go to my formula sheet, where is it on my formula sheet? There we go. The frequency observed, in this case they use the frequency of the listener, is the velocity of the wave plus or minus the velocity of the listener, and the velocity of the wave plus or minus the velocity of the source. Now I only use velocity observed is the velocity of the wave minus the velocity of the observer divided by the velocity of the wave minus the velocity of the source times the velocity times the frequency of the source. So why do I only use negative? Well, I don't want to confuse the issue, and so I would rather change the sign of my velocity depending on whether or not they are traveling towards or away from. Okay, so basically it comes down to this, is if you are traveling towards, then the velocity is towards the source. So in other words, here's the source, there's the waves going out. Okay, so the velocity of the waves is in that direction. Okay, the waves are moving in that, here's the listener, so the velocity of the waves is in this direction. If I'm traveling towards or in the opposite direction of the wave, in other words, what I mean is that this velocity, so this one is positive, it's automatically positive. So if I'm traveling towards it, I'm traveling in the opposite direction, which means I must change this one's sign. So that one would become negative, let's say 20 meters per second, whatever my velocity is, and that negative will make it positive. If I'm the source, so remember this is the source, in what direction is the source traveling? Let's say the source is traveling in this direction, but the listener is hearing the waves are coming to him, let's say to the waves are moving west. Okay, now the source is moving east. So the source will also get a negative. On the other hand, if the listener was moving in the same direction as the wave is coming from, so the wave is heading towards him, the wave is always heading towards the listener. So if the source is also heading towards the listener, we would keep this positive, and so this would stay a negative. I hope this makes sense. Nevertheless, maybe you've got another way of remembering it, but I only use that. So in our example, we have that Karabo is traveling towards you at 35 meters per second. Okay, calculate the frequency that you will observe coming from Karabo screaming. You may assume that so there's no evidence that you are moving, so there you are standing. Here's the roller coaster. Karabo is on the roller coaster screaming at the top of her lungs, so the waves are traveling towards you and the source is traveling towards you. You, on the other hand, are standing still. So if we just substitute all of that, what is the frequency that you will observe? Well, the frequency of sound is 343 minus the velocity of the observer. You're the observer, it's 0. Velocity of sound 343 minus the velocity of the source. The source is approaching you, so it's in the same direction, which means we're not going to change this sign to a positive. We're going to keep it like that. It's in the same direction heading towards you as the sound is, and so that is minus 35, and she's screaming at 700 hertz. And so if we calculate that, 343 divided by, and in brackets 343 minus 35 is 308. Okay, so what this basically means, you are going to hear the sound 1,11 times higher than what it is emitted. Okay, so the sound waves are passing you at a rate 1,11 times quicker. So if it was 2 times quicker, you would hear it at 1400, so 1400 hertz. So you are hearing it at higher than what it is emitted. If you were hearing it at a rate of 1, then it would have been the same. If it was half, it would have been 350. So this is kind of like a percentage. If we multiply that by 100, it would tell you the percentage of times that it is not increased, but that you are hearing 111%. Okay, so I'm going to multiply by 700 as my formula suggests. So I'm hearing a frequency of 779 hertz. 779 hertz, 55 hertz. Okay, the next question is to explain how the Doppler effect is used in astronomy to suggest that the universe is expanding. Okay, so how is the Doppler effect used in astronomy to explain that the universe is expanding? Well, distant lights from distant galaxies, so let's say there's a galaxy, we would expect that galaxy to be observed as white light, isn't it? We would expect to see white light, but what we in fact see is that the light is more towards the red spectrum of the is observed more as a redder color, a more red color. That means now red has a lower frequency than normal white light, okay, or is at the lower spectrum of visible light. That means that the light that is approaching us seems to have a source that is moving away from us, and not just moving away from us, but moving away at a velocity that is relative to the velocity of the speed of light. Okay, so how do I put this in a nice sentence? Well, the observed light from distant galaxies tend towards the red spectrum of visible light, suggesting that the source of this light is moving away from us at a velocity that is comparable or relative to the velocity of light, or the speed of light. Does that make sense? I hope so. Well, that's me for this video. It took me 10 minutes to do 9 marks with explanation, so you should have caught up on some of the time that may have been lost in a previous question. Actually, I would suggest that you start with your Doppler effect question. It's usually not more difficult. Next up, we'll look at the last question in this question paper, which was electricity.